Hello everyone, I welcome you all to this lecture. In this lecture, we are going to discuss the expansion of MUX. So let's say we are having one type of multiplexers. Let's say we are having 2x1 multiplexers. And in case it is being asked that we need to construct 8x1 or 16x1 or 32x1 multiplexer, how we can solve such kind of problems. So generally in the examinations like GATE or NET, they ask the construction of such kind of multiplexers. So the very first thing we need to take care about, in 2x1, 2 to the power 1 cross 1 MUX, when we are saying, we do understand that there is one select line and it can have two inputs. So it can accept, it makes two inputs and it will generate one output, right? So this is output. We are trying to construct 8 cross 1 MUX. In this, we need to handle 8 inputs and obviously only one output we want finally. We are having only these categories of MUX, 2x1, and we need to construct this type of MUX, 8x1. So this is the question. Now we do understand that we need to combine 2x1 MUX, right? So at very first level, at input layer, let's say we are having 8 inputs. Whatever the combination we form, but anyhow we must be able to handle all the inputs. So let's say I'm mentioning inputs. This is input 1, this is 2, or you can say I0, I1, I2, then this is, let's say, I3, this is, let's say, I4, this is I5, this is I6, this is I7. So these are the 8 inputs. I'm naming them like from input I0, I1, I2, I3, I4, I5, I6 and I7, right? So because we have only 2x1 MUX, 2 input we can pass by constructing or by having 2x1 MUX. So let's say I'm having 2x1 MUX. So here we are having a 2x1 MUX which can take 2 inputs, only 2 inputs it can take. So these first two inputs we are passing to this MUX, right? Similarly these two inputs, so we need another MUX. We have, let's say, this another 2x1 MUX. So we can pass these two inputs to a multiplexer which is also 2x1, like this. Now these two we can pass to another 2x1 MUX. And so on. So there is fourth, right? So to handle 8 inputs, we need 4 2x1 MUX. That is very easy to understand. So this is 2x1 MUX. This is also 2x1. This is also 2x1. This is also 2x1 because we are only having 2x1. And these MUX are generating outputs like this. So one output. Now again we are having similar situation. We finally need only one output as it is required here. Only one output we require, but we are having 4 outputs. So again we need to start passing these outputs to MUX. So let's say I copy this, let's say. So I'm copying this first MUX circuit and let's say I'm having this. And let's say another, also we are having this 2x1 MUX. Now establish the connection. So we can connect them like this, and this output we can connect to this MUX like this. Similarly, this we can connect to this multiplexer like this, and this thing can be connected to this multiplexer like this. Okay, but still we are not having single input, so we again need to have 2x1 MUX. So one more 2x1 MUX we will require. So let's say I copy this, and let's say we are having this. Now you must be able to understand how we are getting 8x1 MUX by only having 2x1 MUX like this. So now this circuit will behave. Select line I am not mentioning here. Oh, you know that 2x1 will have one select line. So select lines are there. So these inputs, 8 input, and finally we will get one output here. So that output, let's say you are getting final Y, and this overall circuit will behave like 8x1 MUX. So if I inbox this circuitry like this, so inside there are only 2x1 MUX, but overall behavior of this circuit will be like 8x1 MUX. So this overall circuit will behave like 8x1 MUX. Now if you talk about the select lines, at one level one select line will be activated, so these all the MUX will be connected to a select line, right? So let's say there is one select line, another select line is here, another select line here. So there'll be 3 select line, because ultimately this circuit is acting as 8x1. So I'm considering this is a select line. 8x1 MUX will have 3 select line, one will be here and another will be. So I hope you can understand. The overall circuit will behave like 8x1 MUX, and the total number of required 2x1 total, how many? 4 plus 2 plus 1, total 7 2x1 MUX required, right? So let's say if you have another problem in which you need to construct 16x1 MUX using 2x1. So how many? Let's discuss how many. So let's say there's a question, how many 2x1 MUX will be required to construct 16x1 MUX. So easy way, you can opt very easy way rather than drawing it. You can decide level wise. So at very first level we need to decide how many MUX will be required. So what we need to do is we are having 16 total input line, and my given MUX can handle 2 at a time, so we divide this thing and we are getting here 8. So that means at the very first level we require 8 multiplexers. Now at second level, next level, because we are getting 8 output, we need to handle 8, but we are having only 2 cross 1 MUX, which can handle only 2. So we require here 4 MUX at second level, right? These 4 MUX will give us 4 lines. So at third level, we need to put 4 divided by 2, that is 2 MUX. So we require 2 MUX at third level, and there will be fourth level also, because until and unless we get 1, fourth level, that is 2 divided by 2, so there will be 1 2 cross 1 MUX. So the total required 2 cross 1 MUX is equal to 8 plus 4 12 plus 2 14 plus 1 15. I hope it is clear, right? So let's discuss another problem on the same concept. So if I ask you how many four cross one mugs will be required to construct let's say 32 cross 1 mugs. Now this is a question. You can think for a while, pause the video, and then you can solve. So decide level wise. So the very first level, at very first level, there are 32 inputs and we are having a mux which can handle 4 at a time. So at very first level, we require 8 4 cross 1 mux. Now at second level, we are getting 8 output of these mux, 8 mux. We are having a mux which can handle 4 at a time. So we require 2 mugs at second level. Now at third level, how many mugs we require? We divide 4 divided by 2 divided by 4. So we are getting 2 outputs of these 2 mugs, but we are having a mux which can handle 4 at a time. So obviously this mug, at least one mug we will put here. We can utilize 2 input line of this mugs, 2 will remain unused. So here we will require 1 mug. Do not consider 2 divided by 4 is giving 1, but we want to handle these 2 input lines and we don't have any other choice. We have only 4 cross 1 mux, so 1 mux will be required here, right? So total 4 cross 1 will be 8 plus 2 plus 1, so it is 11. I hope you are getting. So with this I am closing this lecture. Thank you.